Dear students, imagine that you are designing an automated production line where robots need to efficiently and precisely transport parts along the line. To achieve this goal, we need to create a material handling workstation with additional access. Today, through hands-on practice, we will learn how to complete this task. By the end of this lesson, I hope that you will be able to master the method of creating a material handling workstation with additional access in RoboGuide, including adding work tables, tools, and setting up tool coordinate systems. You should be capable of independently creating and debugging the parameters of the handling workstation and possess the ability to troubleshoot when parameters are abnormal. We aim to cultivate a rigorous scientific attitude and a strong sense of responsibility. Let's begin task 3, creating a material handling workstation with additional access. After completing the creation of the additional access, we need to add the robots tool, set up the tool coordinate system, and add other components. First, add the work table. In the left-hand menu, locate fixtures, right-click and select Add Fixture. Then choose Box. Modify the position of fixture 1 to X1000, Y2000, Z1000. Next, create another identical fixture and modify fixture 2 to X1000, Y-2000, Z1000. Next, add parts. In the left-hand menu, locate Parts, right-click and select Add Part. Then choose Box. Modify the size of Part 1 to X, Y, Z150 and click Apply. Now, open the properties of Fixture 1 and Fixture 2. Select the Parts tab. Check Part 1 and click Apply. Check Edit Part Offset. Modify the Z-direction offset to 150 and click Apply. Next, select the Simulation tab and click on Part 1. Uncheck Allow Part to be placed. This step will facilitate the subsequent simulation program writing. After completing the settings for Fixture 1, close the Properties window. Next, open the properties of Fixture 2. Select the Parts tab. Check Part 1 and click Apply. Check Edit Part Offset and modify the Z-direction offset to 150 and click Apply. Next, select the Simulation tab and click on Part 1. Uncheck Allow Part to be picked. With these steps, we have completed the settings for fixtures and parts. Next, create the tool and its tool coordinate system. First, in the top menu bar, click on Lock or Unlock Teach Tool selection. Change the position display to joint. Modify J5 to -90 and press Enter on the keyboard to complete the change. Next, Open the robot controllers in the left-hand menu. Expand GP1, expand tooling. Select UT1, right-click, and choose Properties. In the General tab, under CAD File, select CAD Library and choose Grippers. Select an open gripper model and click OK. Then click Apply. If the gripper's position is incorrect, we can click on the gripper model and rotate it to the correct position. After completing the addition, the next step is to add the gripper closing animation. Select the Simulation tab, and in the gripper settings section, set function to clamp. In the actuated option, select CAD Library. Choose the gripper closed model from the library, and click OK. Then click Apply. And we can perform a test of the gripper opening and closing. With these steps, the gripper opening and closing animation is now set up. Next, we need to set up the tool coordinate system. Select the Util tab and check Edit Util. Then drag the TCP sphere downward. After completing the drag, click Use Current Triad Location and then click Apply. Next, select the Parts tab, check Part 1, and click Apply. Check Edit Part Offset. Rotate Part 1 to orient the block's Z-axis upward. We can also modify the W offset to -90 and then fine-tune the position of Part 1. After completing the settings, click Apply to finalize the tool coordinate system setup. With this, we have completed Task 3, creating a material handling workstation with additional axes. Here, I would like to share a case with you. In a certain automobile manufacturing plant, a technician, due to negligence, set the gear ratio incorrectly while configuring the additional axis parameters. This caused the robot's movement speed to become abnormal and ultimately led to a production accident, resulting in significant economic losses. This case reminds us that configuring parameters for industrial robots is not just a technical task, but one that requires a high sense of responsibility. As future engineers, we must possess a rigorous scientific attitude and a strong sense of responsibility to ensure that every parameter setting is accurate and error-free. In this lesson, we have learned how to create a material handling workstation with additional axes. Through hands-on practice, you have not only acquired the technical skills but also recognized the importance of the rigor and accuracy of parameter settings. I hope that in your future studies and work, you will always maintain a rigorous scientific attitude and a strong sense of responsibility, and contribute to the development of industrial automation.